Hi guys, welcome back to Technowizard. In the previous video, we have seen some questions of network from the JB Gupta book. So we'll continue that only. So let's start with today's question. So this is our first question. In this question, okay, let me select pen. Okay, so this is first question. In the figure given below, the value of R is, okay, we need to calculate the value of R. Okay, so in this circuit we can clearly see these two 10 ohm resistance are in parallel, so their R equivalent will become 5 ohm as two 10 ohm resistance are connected in parallel. So our circuit will reduce to, this is 100-volt battery already they have given us, and there is a resistance R through which a current of 8 ampere is flowing. Now these two 10 ohm resistance are in parallel, so it can be reduced to 5 ohm, right? So now already they have given us everything, current and voltage, so we'll simply put in the formula R plus 5. So they have already given us the value of current, which is 8 ampere. The voltage given is 100 divided by R plus 5. So we'll simplify this. Okay, 8R plus 40 is equal to 100. So 8R will be equal to 60. So resistance will be equal to 60 by 8, which will be simply 2 and 15, that will be 7.5 ohm, right? So for this question, option C is right. So let's see our next question. Okay, in this question it is asking, okay, let's a second. Okay, for next question is the equivalent resistance between the points A and D is, okay, so these are the 2 points A and D. We need to calculate the equivalent resistance between these 2 points. So you can simply assume that there is a voltage source connected between these 2 points, because we need to calculate R equivalent. So I've connected a V volt battery and I current will flow through this, right? So you can see these B point and C point, they are connected with the 10 ohm resistance. So this 10 ohm resistance will be considered as dummy because no current will flow through them, right? Because there is no path available, so current will be zero. So these two 10 ohm resistances can be neglected because no current will flow through them, hence no voltage drop. So now our circuit will reduce to, this is 10 ohm resistance. Now these two 10 ohm resistance are in series, so we can draw it like, right? So what I have done is these two 10 ohm resistances will be in series, so it will become 20 ohm. Similarly, these two are also in series, will become 20 ohm. This is already 10 ohm and this is A point. Now this is 10 ohm and this is D point, right? So we can simplify, these two are in parallel, it will give 10 ohm. Now these three 10 ohm resistance are in series, so simply R equivalent will become 30 ohm, right? So option C is correct. So let's see our next question. Okay, in this circuit it is saying that what is the value of current I in the circuit shown. Okay, so they have given us a circuit and we need to calculate the value of I. So basically this circuit is a bridge circuit, and we know that a bridge is balanced when the product of opposite arm is equal. For example, if I draw a bridge, right, I've drawn a simple bridge and I have connected a galvanometer between these 2 points and a voltage source here, right? So if this is P, sorry, if this is P, Q, R, S, then this bridge will be called as a balanced bridge if the product of opposite arm, I mean P into S, the product of P into S will be equal to R into Q. So this concept we're gonna use in this question. So this is a bridge, and in this the opposite arm are these 2 ohm and 3 ohm, and this 2 ohm and 3 ohm, they are opposite arms, so their product will be 6 and their product is also 6. So the bridge is balanced, so current through this 2 ohm will be 0, right? So we can remove this branch 2 ohm. Similarly, this 3 ohm and 6 ohm, and these are also balanced, so we can also remove this 3 ohm resistance. So now our circuit will reduce to, so they both will come in what, series, so will result into 4 ohm, 2 plus 2, right? Next will become 3 plus 6, 3 plus 3 will result 6 ohm, and similarly these 2 6 ohm will result 12 ohm, right? Next is a voltage source of 6 6 volt is already given, right? And we need to calculate the current I, so we will simplify this network. So when 4 ohm and 12 ohm are in parallel, they will give 4 into 12 divided by 16, so it will give 3. Now 3 ohm will be in parallel with 6 ohm will give 2 ohm, so our circuit will reduce to R equivalent we have calculated as 2 ohm, a battery of 6 volt, and we need to find out simple current. So here current will become 6 by 2, which is 3 ampere. Okay, so for this question option C is right. So let's see our next question. Okay, so this is next question, and okay, two bulbs of 100 watt and 250 volt and 150 watt 250 volt are connected in series across a supply of 250 volt. The power consumed by the circuit is, okay, so let's first draw a bulb. Okay, suppose this is our bulb and this is another bulb. They have already mentioned it is 100 watt and it is 150 watt, and both have 250 volt and 250 volt. They both are connected across a supply of 250 volts. We need to find out the power consumed by this circuit. Okay, so basically there is a formula for such type. If we need to calculate the total power consumed by the bulb connected in series, if the two bulbs are connected in series, so formula will be like P1 P2 upon P1 plus P2, where P1 is the power consumed by the first bulb, P2 is the power consumed by the second bulb. So they have already given, right? So simply put the values, 100 into 150 divided by their sum will become 250, right? So we need to simplify this, so it will simply become 3 by 5, so this will be 20, so answer is coming as 60 watt. So do remember this formula, it's very important. If the two bulbs are connected in series, this formula is valid, right? And suppose if these two bulbs are connected in parallel, then the total power consumed will be their sum. For example, you can consider our houses, all the appliances are connected in parallel, so the total power consumed will be 250 watt in parallel, right? So let's see our next question. Okay, so next question is, two incandescent light bulbs of 40 watt and 60 watt ratings are connected in series across the main, then the bulbs together consume 100 watt. Okay, so 100 watt and 60 watt bulbs are connected in series, right? So it's 40 watt and this is 60 watt, they are connected in series. So I've already told you the formula. So total power consumed by both the bulbs will be P1 P2 upon P1 plus P2. So simply put the values, 40 into 60 divided by 100, so it will come around 24 watt, right? So the bulb together consume 100 watt. This option is wrong, because if the bulbs are connected in parallel, then the total power consumed by the bulb will be 100 watt, but they are connected in series, so this option is wrong. This is also wrong because they will consume 24 watt. Now which bulb will glow brighter, right? So you can understand like this: if the bulbs are connected in parallel, as they are connected in our houses, all the bulbs are in parallel, then the 60-watt bulb will grow brighter, right? The bulb whose rating is higher will glow more brighter. The reverse case is in series, so they are connected in series, so 40-watt bulb will glow brighter. So option D is correct if the bulb is connected in series, and if it has mentioned they are connected in parallel, then option C will be right. So option D is right for this question. Okay, let's see our next question. So this is our next question. Okay, so how many 200 watt to 220 volt incandescent lamps connected in series would consume the same total power as a single 100 watt to 220 volt incandescent lamp? Okay, so they are saying that they have given us 200 watt to 220 volt. We need to calculate how many of them are connected in series so that they will consume the same total power as consumed by a single 100 watt bulb to 220 volt. Suppose n is equal to 2, it means two bulbs are connected in series, right? So this is 200 watt, this is also 200 watt. I have assumed two bulbs are connected in series, so let's see what will be the total power consumed by them. So total power will be equal to 200 into 200 divided by 400 from the formula P1 P2 upon P1 plus P2. So this will be simply 100 watt, and in the question also it is asking it will be equivalent to 100 watt only, so option D is right. Two bulbs in series will consume the same total power as a single 100 watt incandescent lamp is consuming. Okay, so let's see next question. Okay, which of the following is not a bilateral element? So let's first understand what is bilateral elements. So bilateral elements are those elements whose property is same in either direction. It means, for example, if I'll consider the elements like resistance, inductance, or capacitance, I mean they are called as the passive elements, so their property will remain the same in the either direction. It means if the current is flowing in this direction or this direction, their property will remain same. So the correct answer for this question will be constant current source, as its property will get changed in different direction. So you can also understand like this: if there are quadrants, four quadrants, and if I draw a VI characteristic, something like that, so bilateral elements will have characteristics like this. If this characteristic is there, I mean same characteristic in the opposite quadrant, then the element will be called as a bilateral element, else it will be called as a unilateral element. And the example of unilateral element is a diode, because we know that if diode is conducting in this direction, I mean in the forward direction, its characteristic is something like this: it will be in the forward bias. And if the current will flow in this direction, it will not conduct, and a reverse current will flow I naught. So its characteristic is different in the both the directions, so it is a unilateral elements. And RLC, they are called as a bilateral elements, right? So for this question, option A is right. Next question is also similar: the circuit having the same properties in the either direction is known as bilateral. Okay, so let's see next question. The elements which are not capable of delivering the energy by its own are known as passive elements. So I have told you unilateral elements are those whose characteristic is different in the either direction. Example already told you: diode. Nonlinear elements. So nonlinear elements are those elements which don't follow superposition and homogeneity principle, right? So if the element is following both the theorems, so then the element will be called as a linear element, else it will be called as a nonlinear element. You can simply understand like this only from the graph or the characteristic. If there is same slope throughout, for example this, so in this graph the slope is same throughout, so it will be called as a linear because it has same slope. But if the slope changes at any point, then it will be called as a non-linear because its slope is not constant. So here the slope is different and here slope is different, here the slope is 0. So now the slope has changed, so it will be called as a non-linear. So passive elements are those elements which don't deliver the energy, and active elements are those which deliver the energy or provide the energy to the network. Example, any voltage source, current source, right? So these will be called as active elements. So next question. Okay, next question they have given us, the VI characteristics of an element is shown in the given figure. The element is, okay, so they have given us a characteristics and we need to find out which element is this. Okay, so let's see. First understand whether it is linear or a non-linear. So in the first quadrant you can clearly see that the slope is positive, it means it is an increasing slope, right? And in the second quadrant the slope is decreasing, so here the slope is negative. So now the slope has changed from the negative to positive, so slope has changed, that's why it is a non-linear element. Okay, and I have already told you, if the element is bilateral it will have the same characteristics in the opposite quadrant. So here they are not opposite quadrant, so it will be a unilateral element, so it is unilateral, right? So I'll give you a VI characteristic by simply which you can remember this. So if the element lie in the first quadrant, then it will be a passive element, and if the element lies in the second quadrant it will be a active. If it lies in third, then it will be passive, and if it lies in fourth, then it will be called as an active element. Now in this question it is lying in both the quadrant, I mean first and second, so overall it will be considered as active, right? So for this question it is non-linear, active and non-bilateral, it means it is unilateral, right? So for this question option A is correct. Okay, next question is, consider the following circuit, which one of the following statements is correct? Passive linear, active linear. Okay, so in this circuit, see, they have given resistances and a voltage source. So resistances are linear and the voltage sources are also linear. Non-linear elements are like diode, xenon diode, transistor, so they will be considered as a non-linear. So voltage source and a resistance are simply linear, so this is a linear circuit. Okay, now next we need to find out the whether it is active circuit or passive. So simply here current I is coming, now it will divide into two. Here some I1 current is coming and here I2 current is flowing, right? So if I'll apply the KVL in this loop, right, so it will be something minus 5 volt plus, it this will be plus 5 volt, right? So it will overall will be 0 volt. So now this 2 ohm and this 2 ohm only circuit will be like, this is 2 ohm and this is also 2 ohm, and here a voltage is connected and I current is flowing, because they both will cancel each other's effect. So it is simply a active circuit because this voltage source will provide the energy, so it is active as well as linear. So option B is correct. Okay, So next question is, a 3-volt DC supply with an internal resistance of 2 ohm supplies a passive nonlinear resistance characterized by the relation VNL is equal to INL square. The power dissipated in the nonlinear resistance is, okay, let's draw a circuit. So they have given us a 2 ohm internal resistances and a 3-volt DC battery, right? So it is connected across a non-linear resistances whose characteristic they have already given. VNL is equal to INL square. It means there is a non-linear resistances, so current flowing through this will be INL only, because they have given VNL is equal to INL. NL is non-linear, right? So we'll simply apply the KVL in this loop. So this will be plus, this will be negative, because current is entering like this, so it will be considered as positive to show the fact that a voltage drop is occurring across this resistance. So I'll simply apply the KVL. Minus 3 plus 2I plus VNL is equal to 0, right? So from here we can find out the value of VNL will be equal to 3 minus 2I. So this is equation 1. Now they have already given us VNL is equal to INL square. This is equation 2. So we can simplify these two equations, right? So okay, so we have obtained the two equations as V and L is equal to 3 minus 2 INL. This is was equation 1, and they have already given us V and L is equal to INL square, right? So this was 2. So equating both the equations, equation 1 is equal to equation 2. So we'll get INL square will be equal to 3 minus 2 INL. So we can simplify it as INL square plus 2 INL minus 3 is equal to 0. So this is a quadratic equation, we can easily solve this. So it will be INL square plus minus INL plus 3 INL minus 3 is equal to 0. So I have splitted this 2 INL into these, right? So I will take INL common. It will be INL minus 1 and plus 3 common from here. So it will be INL minus 1 is equal to 0. So it will be INL minus 1 into INL plus 3 is equal to 0. So from here I will get the value of INL as 1 and minus 3. So we can calculate the value of VNL. So VNL is equal to INL square, okay? So 1 square is 1 and minus 3 square is 9. So we need to calculate the power dissipated in the non-linear resistance, okay? So power dissipated is simply, power dissipation is given as power dissipated is equal to voltage into current. So we can simply find out the power dissipated, how much power is dissipated in the non-linear resistance, okay? So power dissipated will be equal to VNL into INL. So 1 into 1 will be equal to 1 watt. Here the power dissipated is minus 27 watt, right? So let's see the option. So option A is matching, right? So option A is correct for this question. Okay, let's see our next question. Okay, which of the following statement is correct regarding the resistance? Okay, The resistance of a conductor is the hindrance by which the conductor opposes the flow of current through it. Hindrance is basically the opposition, right? Opposition. So resistance opposes the flow of current. So this statement is right. The resistance of a wire is independent of the temperature for most of the material. Wrong. As we know that resistance is the temperature dependent, given by the relation R2 is equal to R1 in bracket 1 plus alpha into T2 minus T1, right? So here resistance is depending on the temperature difference, and here alpha is the temperature coefficient of resistance, and it is material dependent, right? So it is temperature coefficient of resistance. Next option is the resistance of a wire does not depend upon its material. This option is also wrong, because we know that the formula of resistance is R is equal to rho L by A, where rho is the resistivity and it depends on the material, right? So option A is correct. Okay, next question is the unit of inductance is or are. Okay, so everyone knows the unit of inductance is Henry, right? And we also know the formula L is equal to N phi by I, that is flux linkage lambda per current flowing. So here the unit of flux is what? Weber, and the unit of current is ampere, where n is the number of turns, right? So number don't have any unit. So Weber per ampere is also right. So option C is also correct. And we also know that the voltage across an inductor is given as L di by dt. So from here we can find out the value of inductance as voltage across the inductor into dt by di. So the unit of voltage is volt, dt time is in seconds, and current is in ampere, right? So option B is also right. So option D is correct for this question. All are its units, right? Next question is the current in a coil changes uniformly from the 10 ampere to 1 ampere in half a second. A voltmeter connected across a coil gives a reading of 36 volt. The self inductance of a coil is, okay, so we need to find out the value of L. So they have given us a coil and they have already given us the voltage across the coil is 36 volt, right? And the current is changing from 10 ampere. So current is changing from 10 ampere to 1 ampere in half second. Okay, 0.5 second. So this is time axis, this is current axis. So we know that voltage across an inductor is given as L di by dt. So they have given us 36 volt. We need to calculate the value of L, and d of I is the change in current. So 10 minus 1 divided by dt is a change in time. So 0.5 minus 0, it will be 1 by 2, right? So it will be 36 is equal to L into 9 into 2, right? So it will be, so here the value of inductance is coming as 2 Henry, right? So option C is correct. Let's see next question. Okay, so next question is a coil of inductance 4 Henry and resistance of 2 ohm is connected across a 20 volt DC source. The steady state current in ampere through the coil is, okay, so basically they have given us a resistance whose value is 2 ohm and an inductance of 4 Henry, and they are connected across a 20 volt DC source. So we need to find out the steady state current in ampere through the coil. Okay, so let's first calculate the value of inductive reactance, and we know that it is given as omega into L, where omega is the angular frequency given by 2 pi fl, and here the source is DC, and we know that DC has a frequency equal to 0. So here the frequency is 0, so the value of XL will be 0 ohm. It means the inductor will be short circuited. So now our circuit will simply reduce to 2 ohm connected across a 20 volt so DC source, and inductor is short circuited, so the current will be simply 20 by 2, that is V by R, that is 10 ampere. So option C is correct, right? So next question is this. Okay, so in this question they have given us the voltage and the current waveform for an elements are shown in the figure. Okay, so they have given us a current waveform and a voltage waveform. We need to find out the circuit elements and all and its value. Okay, so you must know there are two properties, one for the inductor and one for capacitor. Inductor property is that it does not allow the sudden change in current, right? So it don't inductor don't allow the change in sudden change in current. Similarly, capacitor don't allow sudden change in voltage. So do remember this property, it's very important. And see here, in the voltage waveform the value of voltage has changed suddenly from 2 volt to 0 volt at t is equal to 2, right? So it means this is not a capacitor circuit, because if the capacitor have been present in the circuit it won't have allowed the sudden change, but here the voltage is changing suddenly. It means the circuit element is inductor. Now we need to find out its value. Okay, so for the inductor we know that voltage across inductor is given as L di by dt. So the voltage is given as 2 volt, and the change in current, so the voltage across the inductor is given as 2 volt, and here the change in current is from 2 minus 0 divided by in 2 seconds, right? So 2 minus 0, so it will be simply, so voltage across inductor is 2 volt. We need to find out its value. The change in current is 2 minus 0 divided by change in time is 2 minus 0, so it will be simply the value of inductance is coming as 2 Henry. So see the option, right? So it is inductor and its value is 2 Henry, so option C is correct. Okay, so next question is, which of the following statement associated with the inductor is wrong? Okay, an inductor is a sort of short circuit to DC. I have already told you, if you will calculate the value of inductive reactance, right, it will be omega into L. Omega is 2 pi fl, right? So for the DC frequency is 0, right? So XL will be 0. It means inductor will be considered as a short circuit if it is connected across a DC. So this option is right. Next option is, an inductor is a sort of open circuit to DC. This option is wrong. Capacitor will be open circuited to DC and inductor will act as a short circuit. Next is, an inductor never dissipates energy but only store it, right? It's a property of inductor. Inductor is designed to store the energy. If it is a practical inductor, it will dissipate very small amount of energy, but if we'll consider idle inductor, it is designed to store the energy only. Resistor will dissipate, so option C is also correct. And next option is, a finite amount of energy can be stored in inductor if even if the voltage across it is 0, such as when the current flowing through it is constant, right? So we know that the amount of energy stored in the inductor is given as half of L I square, right? So energy stored in the inductor is depending on the value of current flowing through it, right? It is not depending on the voltage, so definitely it will store some energy if the current is flowing through the inductor. So this option is also right. So in this question it is asking we need to find out the wrong statement, so option wrong statement is B, so option B is correct, right? So okay, so that's it for today's session, and see you in the next lecture. Till then, bye.